We're continuing on with part 2 of pre-transfusion testing. Some general considerations. Labeling. Each tube is labeled properly before use. The recipient's initials or other identifying information, and a donor unit number or reagent red cell identification. So for me, I put the first and last initial at the top of the tube. Why at the top of the tube? Because when they're in the heat blocker, when they're in the rack, I can still read the information. For donors, I write the number down the side of the tube, and then forever after that will be donor 1. And then I write the next one, and that will be donor 2. So from there on out, I will label tubes with 1 and 2. The system must allow for accurate, rapid labeling. And if you are an individual who one by one labels your tubes, blood banking is not for you. You grab a gaggle of tubes out of your box, lay them down flat with your hand on top, with the tops of the tubes at the top of your hand. And that way you can label very, very quickly. I can get 50 tubes labeled in probably less than a minute, less than 2 minutes, and put in the racks. Again, you never label tubes one by one by one. Your patient will bleed to death while you're labeling your tubes. Never rely on the position of a tube in a rack or centrifuge head to identify the contents of a tube. So, again, I can go on and on about mistakes made, but I always put my first tube that I'm going to read in position 1 of the centrifuge, and then so on. I've had students just willy-nilly put their tubes all around, and then they spend 10 minutes when they pull it out, putting it in the correct order, and then shaking and reading it. That doesn't go on for too long. And it's a matter of not being familiar with these procedures. Please don't think I'm making fun of you, but I want you to know there are very few ways in the transfusion service that we can gain time. We cannot eliminate incubation. We cannot eliminate the number of tubes. What we can do to decrease the amount of time is be as efficient as possible at labeling and then getting the necessary components into the tube. So again, always place tubes in the centrifuge in the order that they will be read, and use the same organizational techniques when labeling and arranging tubes in a rack to improve your organization and your speed. Volume of serum or plasma, as we've talked about, the antibodies are present in the serum or plasma. So the ratio of antibody to antigen is crucial. Most procedures call for 2 drops of patient's serum or plasma. Research has shown that 2 drops provides the optimal antibody to antigen ratio, so we don't end up with prozone or post-zone. Some alloantibodies are detected only when 3 to 4 drops are used. And there is a high variability in the delivery and transfer pipettes. Theoretically, a transfer pipette should deliver 20 drops per ml. And we don't need to be specific. We don't have to use a serological pipette or a micropipetter, but just be aware that you always want to hold your droppers straight up and down. That is how they are designed to deliver. If you tilt it, you're going to end up with a drop that is larger than what you should be using. Standardized volumes based on equipment used in your laboratory. For low ionic reagents, which are your potentiators, they require a ratio of 2 drops of serum or plasma to 2 drops of bliss. You cannot vary this. For example, with albumin, I can add 3 or 4 drops of serum and 2 drops of albumin. That's okay. But the manufacturer's instructions specifically state that you cannot alter this ratio of 1 to 1. Which in the procedure we use 2 drops of serum and 2 drops of bliss. Cell suspensions. Red cells used for cross-matching are obtained from a sealed segment of original tubing attached to the blood container or blood bag. So the tubing that went from the donor arm to the blood bag, that's the blood flow to it, as soon as the donation is done, they heat seal that tubing at specified distances, and it contains a number unique to that donor unit. We then take that segment, and you can either snip the end off and squeeze a little bit of blood out, or most transfusion services have now gone to these safety devices where the blue device is put over the 12 by 75 tube, and then the segment is squished into it till it's pierced by the needle, and you squeeze to dispense a few drops of blood. You never dispense all of the blood, just a few drops. You want to wash it once and prepare a 2 to 4% suspension. Some workers prefer a 2% as it increases the sensitivity of the test system. This would not be you, because this would require a person with a great deal of expertise. Because when you use a 2% suspension, the button is very small, and so you could easily overlook a positive reaction. It's best to use the weakest suspension that can be observed for agglutination. Too heavy of a cell suspension can cause weak antibodies to be missed. So what is this called when we have too many antigens but not enough antibodies? It's called post-zone. So again, pulling back this immunology is a key component to understanding transfusion medicine. We'll talk about the different testing techniques. The first one is the saline tube. It's the simplest to perform. You mix serum or plasma with saline suspended cells, centrifuge, and read, and record. And then you incubate at room temperature or 37 degrees, depending upon what this testing is for. This is used primarily in cross-matching to detect ABO incompatibility. In antibody tests, it's used to detect IgM antibodies, which react preferentially at room temperature. And I'm planting a seed here. Anti-M, N, P1, Lewis, and I are the most common blood group antibodies that react at room temperature. So as soon as I see positives in my screens at room temperature, I'm thinking one of these guys. Rare examples of antibodies of other specificities may be observed at room temperature, but more often will be reactive at 37 and or Coombs as well. Bovine albumin. This is utilized to enhance agglutination of IgG antibodies since 1945. It decreases the amount of time required for incubation. If you're using a saline test, minimum incubation is 30 minutes. With bovine albumin, we were able to decrease it to 20, even in an emergency situation to 15 minutes. Every little piece of time that we can save in the process means that we can get the blood to our patient faster when they need it. Controversy is, does it decrease the zeta potential, which affects the second stage of agglutination, or due to the function of ionic strength of the albumin diluent, does it increase uptake of antibody onto the cells, which is the first stage of agglutination? So that's the controversy. I always thought it decreased the zeta potential, allowing the cells to come in closer to where if the antibody was attached, we would get agglutination. Many antibodies have enhanced reactivity when albumin is added to the test system. Low ionic strength saline, LIS for short, shortens the incubation time needed for the serological reaction. It increases antibody uptake onto the cell, which enhances the first stage of agglutination known as sensitization. Several important factors to consider: the incubation time and the sensitivity subsequent to Coombs depends upon the desired ionic conditions. Adding additional serum will increase the ionic strength and must not be done. I stressed this in the previous slide. The list is 2 drops of serum or plasma plus 2 drops of LIS. No exceptions. You must adhere to the manufacturer's instructions. Polyethylene glycol, also known as PEG, is a water-soluble neutral polymer, which is an effective potentiator of antigen-antibody reactions that competes with water for space around the red cell. The exclusion of water molecules allows the red cells to get closer together and concentrates antibodies around the red cell surface. Both of these changes makes it more likely that an antibody will bind to its corresponding red cell antigen. So some of the advantages that PEG has over albumin includes it increases the rate of detection of clinically significant antibodies, which is something we really want. It decreases the detection of clinically insignificant antibodies, ones that, even though they're present, will not harm the patient, which is another thing we really want. And it may decrease the need for other enhancement techniques. The procedure, you add serum or plasma to the red cells, you perform an immediate spin, record the reactions with the tubes in your hand as they're read. Then you add the PEG and you incubate at 37 for the specified period of time. After the incubation is done, it is not read. I want to say that again. After incubation, you do not spin and read these, because polyethylene glycol, if you spin it after 37, it could cause irreversible sticking together of the cells, not because of an antibody being present, but because of the nature of the additive solution. So again, PEG, don't read after 37. You immediately wash and you add Coombs and proceed as before. Many transfusion services are using PEG as their primary enhancement media when using the tube system. Another tool in our toolkit are enzymes. These are more appropriate for antibody identification rather than routine testing. Enzymes greatly enhances the reactivity of Rh antibodies. I've seen them go from a 1 to 2 plus to 3 to 4 plus. And so this is a tool I will use when I have very weak reactions. Perhaps the specificity is undetermined, and then I use my enzymes, and boom, here we go. There's the name. Enzyme-treated cells cannot be the only method used to identify antibodies to M, N, S, or Duffy and other antigens, as these antigens are destroyed by the enzymes. So those antibody specificities would not be detected. So for example, let's say I had anti-Duffy A, and I decided I would test this antibody against enzyme-treated cells. Well, instead of enhancing the reactivity of the antibody, I'm going to get a false negative because the enzymes have destroyed the antigen on the cell, and now there's nothing for that antibody to attach to. So I get a false negative. The enzymes used include papain. This is a proteolytic enzyme extracted from the raw fruit of the papaya plant. And what I found interesting is that my local grocery store, they use this to tenderize fajitas, which I thought was kind of interesting. Bromelain is a group of enzymes found in pineapple juice and in the pineapple stem. Trypsin can be made from bacterial or fungal sources, but is most often extracted from the pancreas of pigs. It's called porcine trypsin. And physin is an enzyme derived from fig latex, which I never knew there was such a thing. This concludes part 2 of Unit 8. Again, spend quality time with your textbook. Do those questions at the end of the chapter. Do those case study presentations. Always apply your knowledge to these case studies. I can bring anybody in off the street and teach them how to add drops of this to drops of that and read for a good nation, but I can't teach them how to apply their knowledge. You need to know what's going on in each and every tube to know and come to a correct conclusion. So again, write down any questions you may have, and that's it for now.